In this video, I'll continue working on the Test 6 review. On number 10, we're using the change of base formula to get an answer to 4 decimal places. And it does say show at least one step, so we want to see this one step where you actually use the change of base formula. And the way it works is it's going to be the log of the higher number over the log of the lower number. And that's how we use the change of base formula. So notice now the base is 10, it was 6. And if you just put it in the calculator just like it looks there, using division after you put in the first log, you should get 1.3979. Now the thing about these is you should never get one of these wrong on the test because you can easily check this. Remember, a logarithm is an exponent. The answer we just got is the exponent you put on a base of 6 to get 12.24. So if we put it on 6, we should get 12.24. And if you check that, you'll see that it does work. And so there's no reason to miss these. You can check these. Sometimes people will put the numbers in the opposite, where the log of 6 would be in the numerator. So I just remember the higher number stays in the numerator, the lower number goes to the denominator. So on part B, I would write the log of 15 over the log of 1/2, or you could just make the 1/2 0.5. 1 divided by 2 is 0.5. It makes it a little bit easier. Or just put it in as 1 divided 2. And when you do that one, you should get negative 3.9069. And again, if you want to check it, 1/2 to this power should equal 15, and you can verify that it does. On letter C, it's going to be the log of 250 over the log of 13.5. When you plug that into your calculator, you should get 2.2114. And if you check that, it'll be 13.5 to this power equals 250, and you can verify that that does check. All right, let's look at number 11. So it says use the properties of logarithms to expand the given expression as much as possible. So all of these are single logs, and when we're done, they're going to be multiple logs, and in each case it'll be the log of a single number or a single binomial. So let's go ahead and review our properties. We've got the product rule, which says the log of a product equals a sum of logs. We've got the quotient rule, which says the log of a quotient, m over n, is equal to the log of m minus the log of n. So again, it's the log of a quotient is equal to a difference of logs, or a subtraction of two logs. And then the last one is if you have the log of a power, in this case m to the p, you can pull that p power out front, or your exponent just comes out front, and that's the power rule. I'm going to just refer to these as properties 1, 2, and 3. So if you look at the first problem here, letter A, you have the natural log of a product, x cubed times y, and you also have that power x cubed. Now, if you didn't have the y here, you could just pull the 3 out front. But you can't pretend the y is not there and use the power rule. If you look at the third rule, the power rule, you just have m to a power. You have a single number to a power. That's not what we have in this problem. But we do have a product, and we can certainly break it into 2 using the product rule, our first property. This becomes the natural log of x cubed plus the natural log of y. And see, now we do have x cubed by itself, and so we can pull that 3 out front using the third rule, and we get 3 natural log of x plus the natural log of y. And notice we have the natural log of x and the natural log of y. There's nothing we can do any further to expand, and so we're done. On letter B, we have the log of a quotient, and so we're going to use property 2, the quotient rule. It'll be the log of x minus 4 minus the log of 3. Notice our base here is 10. Of course, in letter A, it was a base e log since it was natural log. Look at letter C. Notice we have a product of 64, x cubed, the square root of y plus 2. So we're actually going to use the product rule twice here. Notice we will need to use the power rule, but again, to move that 3 off the x, you can't do that when you have the 64 there and the square root of y plus 2. So again, you can't just ignore these parts here and move out the 3. You're going to have to get that x cubed by itself before you can do that. So it'll be the log base 4. Or I'm sorry, I want to remind you that the square root of x is equal to x to the 1/2 power. So we're going to write that y plus 2 as y plus 2 to the 1/2 power when we break this into 3 sums. So it'll be the log base 4, we are using property 1, log base 4 of 64 plus the log base 4 of x cubed plus the log base 4 of y plus 2 to the 1/2 power. So you can see now we can move our exponents. So we'll use property 3 next. Oh, the other thing we should notice here is the log base 4 of 64 is actually a logarithm we can evaluate, because isn't 64 a power of 4? So again, remember, a logarithm is an exponent. In this case, it's the exponent you put on a base of 4 to get 64. And of course, that's going to be 3. And so this has a value of 3, this logarithm. So we're going to put a 3 there, and then we can pull out the 3. Now we're going to use the power rule. We'll pull that 3 out front. We get 3 times the log base 4 of x. And we can pull the half out in the last one, and we get 1/2 the log base 4 of y plus 2. Now you might be tempted to want to do more here, but we don't have a property that allows us to simplify the log of a sum. We have the log of a product, the log of a quotient, and the log of a power. Those are the only things that we can break down further. So this one's done. All right. Let's look at letter D. So in this problem, again, actually we're going to have to use all 3 properties. Notice if you just ignored this part here, the numerator, you could use the product rule, but you can't just ignore that denominator. It's there. And the same thing with the power rule. You can't move that 2 until you get the u squared by itself. So the only rule that I can use is the quotient rule. So that's rule 2. So it'll be the log base 7 of our numerator minus the log base 7 of our denominator. Now, if you look at each of these, we can use the product rule. So it'll be the log base 7 of 49 plus the log base 7 of u squared minus the log base 7 of w plus the log base 7 of z. Now be careful here. We just replaced this log with these 2 logs. And so that minus affects both of the logs. And so what I want to do here is put parentheses, or you could just make both of the signs negative, which is what I'll do in the next step. Now let's move to the next line. We've got the log base 7 of 49. Again, that's a logarithm we can evaluate because 49 is a power of 7. What exponent do you put on a base of 7 to get 49? That would be 2. And then we can pull the 2 out on the next log using property 3. And then let's distribute the negative. It would be minus log base 7 of w minus log base 7 of z. And that's going to be our final answer. All right, so on 12, now we're going the opposite direction. So notice on A there, that's a sum of logs, so that's our first rule. I'm going to go ahead and write down the rules again. So let's see, we've got the product rule, the quotient rule, and the power rule. So clearly we need to use the first rule where we have a sum of logs. We're just going the opposite direction. So we can multiply the x and y and make this into 1 log. That's all that we need to do here. So notice the directions are a little different here, and it says rewrite each expression into a single logarithm. Especially when we start solving equations, this is something we do quite commonly, and we call this condensing. We would say condense the logarithmic expression. Okay, so let's look at 2. So when I see this, I can see that I'm going to need to use property 2 because I have a subtraction of logs. The only problem is I've got that 2 out front. And if you look at our properties for the product rule and the quotient rule, there's no numbers in front of the logs. And so we need to deal with that 2 first. And so we're going to use property 3, and we're going to move that 2 to be an exponent for y. So now that these are both 1s, I can go ahead and use the quotient rule, and this becomes the log of x plus 3 over y squared. Notice on letter C, all we have to do is the quotient rule. There's nothing else to do here. So just property 2, and we're done. Now, sometimes students on a problem like this will write log of base 5 of x plus 7 over the log base 5 of x minus 8, and we end up with a log over a log, and that's incorrect. The only time we're going to have a log over a log is when we were using the change of base formula. But with the quotient rule, it's the log of the quotient, x plus 7 divide x minus 8. All right, let's look at that last one there. Again, if you haven't tried this, I would encourage you to try it before you watch the video. All right, so let's see. It's similar to letter B in that we're going to need to get rid of the 2 there and the 1/2 and put those as exponents. So we're using property 3. We'll get the natural log of x squared minus the natural log of y minus the natural log of z to the 1/2 power. All right, and then if you look at the first 2 terms there, we're going to use the quotient rule. So it'll be the natural log of x squared over y minus the natural log of, and we're going to go ahead and write that as the square root of z. So now we're going to use the quotient rule again. Now keep in mind, we're going to have to take x squared plus y and divide it by z. So you got to be careful with this. I'm going to do it off to the side. We could write x squared over y all over square root of z, but that just means division by z. So this, in a case like this, we multiply by the reciprocal. So when we multiply across, we get x squared over y times the square root of z. And so that's what's going to go inside the parentheses. Now there's a really slick pattern here that I want you to notice. And we talked about this in class. So if you look in the front here, it's positive, and that x squared ends up in the numerator. Here you have a minus, and the y ends up in the denominator. Here you have a minus, and the z, square root of z is what we ended up with. We ended up with that in the denominator. So you actually could go from here to here if you see that pattern. All right, let's move to number 13. All right, so now we're solving equations, exponential equations in particular, and notice their directions round to 4 decimal places. So I want to remind you, in problems like these, we can get the bases equal. That's one of our strategies for solving exponential equations. So if you look at the first one here, on the left side we have 2 to the 4x, and on the right side we can write 16 as 2 to a power. It's actually 2 to the 4th power. And so we're just going to replace 16 with 2 to the 4th. And then we do need to multiply the exponents here. This is a power to a power. And when we do that, we're going to have to distribute. We get 4 times 2x, which is 8x, and 4 times a minus 1, which is a minus 4. So now that we have our bases the same, The only way that these two could be equal, these two expressions, if the bases are the same, is the exponents have to be the same. So 4x must equal 8x minus 4. And so that's going to be the strategy for all three of these. We're going to get the bases the same, and then we're going to set our exponents equal. So here we get 4x equals 8x minus 4. Let's go ahead and subtract 8x on both sides. We get negative 4x equals negative 4. We'll divide by negative 4, or you can do that one in your head and you get 1. By the way, it's not too hard to check these. If you plug in a 1 here, you have 2 to the 4 times 1 power equals 16 to the 2 times 1 minus 1 power. Well, on the left, 4 times 1 is 4, so that's 2 to the 4th. On the right, your exponent is 2 times 1, which is 2, minus 1. That's going to be 16 to the 1st. And 2 to the 4th power does equal 16. And so that's our answer. It does work. So again, if you haven't tried B and C, now that you've seen A, you may want to try to do that. It's always better if you can work things out on your own. I'm just here to make sure you understand once you've given it your best shot. So on part B here, again, notice the left side, we've got a base of 4. And on the right side, we can write 64 using a base of 4. So that's what we're going to do. So let's go ahead and, excuse me, put the left side here. Let's write that as 4 cubed to the x minus 3 power. Let's go ahead and multiply the exponents on the right side. It's 3 times x minus 3. And again, don't forget to distribute here. And so you get 4x plus 2 is equal to 3x minus 9. We're setting our exponents equal. So subtract 3x on both sides. You get x plus 2 is negative 9. And so we're going to get negative 11. So again, let's plug in negative 11. This one's kind of a pain, a little bit more than normal. On the left side, we have negative 4 times negative 11 is negative 44 plus 2. On the other side, we're going to have negative 11 minus 3. So we're going to end up with 4 to the negative 42 power is equal to 64 to the negative 14 power. This is, if you put this into your calculator, I'm not even sure that they'll show up as the same number. There is a way to see it maybe a little bit better. On the right side, we could write that as 4 cubed to the negative 14 power, and 3 times negative 14 is negative 42. So you can see these are equal. This one's a little bit more of a pain to show than some of the others, but usually with exponential functions, it's not too much trouble to check your answers. On letter C, again, it looks, if you look at the left side here, we could write that as 3 to a power, and we could do the same thing with the 9 on the right. We know that 3 to the first power is 3, so 3 to the negative 1 power would be 1/3. Whoops, I'm sorry, I forgot to put that last step in on the last problem. So here, it'll be 3 to the negative 1 power to the x plus 2 power is equal to 3 squared to the x minus 4 power. We need to multiply our exponents. You get a minus x and a minus 2 there. You got to distribute the negative 1. And then on the right side, again, you're distributing the negative, or the 2. You get 2x minus 8. Let's go ahead and set our exponents equal. We need to get x on one side only. You get negative 3x minus 2 is negative 8. Let's add 2 on each side. We get negative 3x is equal to negative 6. And so we're going to end up with x is equal to 2. And again, you can check this. 1/3 to the 2 plus 2 power should equal 9 to the 2 minus 4 power. 1/3 to the 4th power should equal 9 to the negative 2 power. Well, if you multiply 1/3 times 1/3 times 1/3 times 1/3, you get 1/81. And 9 to the negative 2 power, well, I know 9 squared is 81. So 9 to the negative 2 would be 1 over 81. And so that is correct. All right, let's go ahead and stop this video here. Actually, I think I'll keep going on this one. Let's see, how much further do we have? Hold on a second. We've got G. All right. Let's go ahead and we'll do these problems here. So on 14D, something doesn't seem right here. Maybe that's 13. I think I messed that up. Anyway, on 14D, we've got 3 to the x power equals 15. And notice on this problem, and it's going to be the same with the other three, we can't get equal bases. 15 cannot be written as 3 to some power. 3 to the first power is 3. 3 squared is 9. 3 to the third is 27. We're not going to hit 15. So the only thing I can do here is switch forms. And so that's what we're going to do. So we'll write log. Our base is 3. The 15 goes there. And remember, the exponent always goes by itself when you're in log form, because a logarithm is an exponent. And you can see here, all we need to do is change the base formula. This will be the log of 15 over the log of 3. And when you put that in your calculator, you should get 2.4650. And again, with these kinds of problems, especially with this type on this slide, these are super easy to check and know that you did them right. If you take 3 to this power, you should get 15. And if you check that, it will come out. It does work. And so that is the correct answer there. So on E, F, and G, you're going to do the same thing. First, you're going to need to change forms. So notice on E, we do have a base of 5, an exponent of x plus 3, and an answer of 32. So in logarithmic form, it's log base 5 of 32 is equal to x plus 3. Excuse me, I'm losing my voice here. Again, the exponent goes by itself, the x plus 3 there. So let's go ahead and use the change of base property. It'll be log of 32 over the log of 5. I'm also going to subtract 3 on both sides. So I end up with x equaling log of 32 over log of 5 minus 3. So be careful when you put that into your calculator. You should get negative 0.8466. And let's check this. It'll be 5 to the negative 0.0846 plus 3 power, and that should equal 32. Just be sure to put this part in parentheses in your calculator, and you should get that you should be able to confirm that works. Letter F and actually G are very similar in that we've got too many parts. If you look at this problem here, if we could just not have the 10 there, we'd have base, exponent, and answer, and we could switch forms. But we've got an extra number here. So the first thing you want to do is subtract the 10. You get 2 to the 4x minus 3 power equals 5. Now let's switch forms. It'll be the log base 2 of 5 equals 4x minus 3. So I'm going to go ahead and add 3 to both sides, but I'm also going to use the change of base formula. It's the log of 5 over the log of 2 plus 3 is equal to 4x. So I'm going to rewrite that over here. Excuse me. The only thing left to do is to divide by 4. So it looks like a mess. The main thing is do log of 5 divide log of 2 plus 3 and hit enter. Make sure you hit enter because you want all that added first, and then you'll divide by 4 and you get 1.3305. So if you put that into we can check this. It'll look like that. When you put that in, you should get 15, and you should see that it does work out. So I'd encourage you to try G if you haven't, now that you've seen these, maybe you can figure that one out and then watch the video. So you should have subtracted 5. You'd get 6 times e to the x plus 1 power equals 18. So now I need to get rid of the 6 because I still have too many numbers. So now notice we have base, whoops, let me use this. We have base, exponent, answer, the 3 parts that we need, and now we can change to log form. It'll be log base e of 3 equals x plus 1. Of course, we would want to write this as the natural log of 3 equals x plus 1. And the only thing to do is subtract 1. And so our answer is going to be the natural log of 3 minus 1. Notice you cannot combine the 3 and the 1 there. And so when you do that, put that in your calculator, you should get 0.0986. Again, I would encourage you to check your answer. You could verify that this does equal 23. Again, put this part in your calculator in parentheses, and it does work. Let's go ahead and stop the video right here.